Guys, this is Team Hotpot. I'm Ziqian and here are my colleagues Yujing and Chuwei. Today we're here to talk about the prediction of YouTube video growth. We built a model that predicts the growth rate from the second to the sixth hour based on a set of features. We hope that this presentation will give you some insight into how a YouTube video becomes successful. Here we got a dataset containing this much observations, each with measurements in 259 features in 4 categories: thumbnail image features, video title features, channel features, and other. Here's an overview. We first started with inputting the training data, and then here is pre-processing by doing feature engineering, model building with random forest, and finally making predictions. In pre-processing, we went through feature creation and feature selection. Simply speaking, by doing feature creation, we create new variables that meaningfully contribute to the model based on the old existing ones. For example, here is a variable called publish date, which contains a time tag for a video. The information is kind of mixed up, so we separate it into several new features. The other approach is feature selection. Here we try to filter out free riders that would not play important roles in prediction. 2 cases that we noticed would be variables of low variance, for example, of the years are 2020, and severe correlation or collinearity, which means the information it carries is also provided elsewhere, so this might be redundant.
Now comes to the model part. Our first motivation is to use random forest. As the name says, random forest relies on several randomly chosen decision trees to make predictions. It's just like having thousands of people making guesses at the same time. The error is thus average, which makes this method reliable. A method based on random forest has 2 advantages. First, it is good at dealing with high dimensionality. High dimensionality means that dataset has a lot of variables. In this case, after feature engineering, there are still 79 features left. So it is important to use a method which can deal with many features. Second, it also provides a validation check. This validation check is called out-of-bag error estimate. It is computed automatically during the process of random forest, so it is totally for free. Here is the performance of our model using training dataset, indicating that at this point, our model provides the best prediction accuracy.
We discovered that there are several key variables that may influence the growth rate. First, videos with higher total views tend to have a larger initial growth rate. Second, views in the first 2 hours are highly related to growth from second to sixth hour. Third, the more subscribers, the more likely it will spread fast. Fourth, we find out that videos published between 8 p.m. and 12 a.m. are more likely to become popular, while less likely from 6 a.m. to 1 p.m. Thus, we make 3 recommended takeaways for our clients. First, they can launch the video during 8 p.m. to 12 a.m. for more initial views. Second, they can purchase promotion of videos in the first 2 hours to get more initial attention. Third, they can build a solid subscriber community with loyalty to view their videos at once. In conclusion, our model has several strengths. First, our carefully designed feature engineering contributes to the accuracy of the model, which prevents biased estimation of video growth rates. Also, the random forest model is good at dealing with a large data set with many features to predict accurately. Therefore, we have low RMSE scores on both private and public board, suggesting that our predicted growth rates are similar with the real data. And our public and private board RMSE scores are consistent with a difference of only 0.003, suggesting that our model performs similarly robustly on different data sets in prediction of growth rate. And that's all of our presentation today. Thanks for listening.